How are t-values and base factors related? So in a typical hypothesis test, you would calculate the t-value as the observed, for example, improvement that patients gained through some medication. You subtract the expected value that you would not care about. So for example, the expected improvement if you gave participants a placebo instead of the medication. And then you divide by the standard error, the variability of your mean values. On the other hand, base factors are conceptually different. They compute the probability of observing your mean improvement given some H1 hypothesis and divide this by the probability given the H null hypothesis. And now the real question to relate t-values and base factors is what is H1 and what is H0? And for this, consider the following perspective. You start at your mu0, your basically null expected effect. And let's say over here is our observed improvement of the patients. And now from the mu0, you go a little bit to the left to some value that is mu0 minus SE divided by 2. And you go a little bit to the right over here to mu0 plus SE divided by 2. And at these two locations, at basically a very slight deviation to the left and at a very slight deviation to the right, you put up normal distributions with a standard error as we assume is given. So the strong assumption here is that these standard errors are perfectly known and not just estimated from the sample. There are of course variants of the same argument with estimated values, but let's keep it like this. We have these two normal distributions with just different means. And now what the base factor wants us to do is basically look at this situation where the where the mean of the x values is observed. And let me blow this up for you. So our x is here and our two distributions, of course, the right one is a little bit higher than the left one. And the base factor wants us to look at these two likelihoods. And this is basically then a likelihood ratio test, and that actually turns out to be, in this particular case, if we have these two hypotheses and the standard error here in this case is known, this corresponds to the Newman-Pearson test, the most efficient test in this kind of setting. So the base factor here does a likelihood ratio test, which is the most efficient thing for this pair of hypotheses. And what it means in particular is, since these two distributions are normally distributed, the right one will be an e to the power of 1 minus 1/2 times mean value minus the expected value of this right distribution, which is mu0 plus SE divided by 2, and then divided by SE. This is basically the first part, the upper part of the base factor, and then we have to divide again by the alternative hypothesis, the left normal distribution, the left hypothesis, which looks very similar. It's also normally distributed, so it has the same functional form, just the expected value is different, so here is a minus instead of a plus. But otherwise, you also have to divide here by the standard error. And if you calculate this out, if you rearrange this properly, you will find that this results to e to the power of mu, your mean minus the mu0 divided by SE, which is t, right? Which is e to the power of t. So in other words, you could also say the natural logarithm of your base factor is your t value. And that's the relationship. I'm not sure how familiar the field is with this. I have been asking myself this question for a long time. But the basic idea here is that the t value is the logarithm of a base factor if you put two normal distributions just around mu0. See you next time.